Hi guys, today we're going to go over a strategy of how to convert units. This is something that's going to be really useful in a chemistry setting because not all of the measurements that you're going to be given are always going to be in the units that you want them to be. For instance, in this country we use the English standard system of units, and in most of the rest of the world they use the metric system. So if you get lab data from someone that doesn't happen to have the units that you happen to use, you want to be able to convert those and understand exactly the numbers that you're working with. So how are we going to go about doing that? Well, I'm going to go over a strategy today that I think will be really helpful and straightforward. If you follow it, it's going to be very hard to get these unit conversions wrong. So how we want to start this is always take the number that you're given. So if we look at this first one, we have 75 meters. If we put down 75 meters there, we want to think, how are we going to get that meters into our desired unit, feet? So we're just going to multiply by some conversion factor. I've given you a bunch of conversion factors up here. We'll use those throughout these practice problems. So how we want to approach this is, well, we have meters and we want to get rid of meters, so we'll put that on the bottom of this fraction. If we put this over 1, we have meters on the top of the fraction in the numerator. We want to put meters in the denominator of this fraction so that meters will cancel out with meters, because anything in the numerator and denominator will cancel out. So what we want is feet. So if we put feet on top here, we've canceled out the meters and now we're in the units we want. So all we have to do is figure out this conversion factor here. We have 1 foot is 0.305 meters, and I just got that from right up here. So then all we have to do is multiply straight across the top, 75, and straight across the bottom, 0.305, and the units that we're left with are feet. So then once you get this, you just divide it out. I'll give you guys a minute to punch that into your calculators. So what you should have come up with there is 245.9 feet. And that would be our answer. We'll do that a little more cleanly. So this, I think, is going to be a really easy strategy to follow. Again, what you want to do is take the first number that you're given, this 75 meters, our actual measurement, and we're going to multiply by some conversion factor to get into the units that we want. So whatever you have on the numerator, you want to put in the denominator to cancel it out and give yourself the unit that you actually want to be working with. So let's try another one here. How many inches are there in 55 centimeters? So if we take the number that we start with, 55.7 centimeters, and we want to multiply by our conversion factor. So we know we want to put centimeters on the bottom, because if centimeters is on top here, we want to cancel it out, centimeters with centimeters in the numerator and the denominator, and what we're looking for is inches. So if we go up here, we have a direct conversion between centimeters and inches. Right here, 2.54 centimeters is 1 inch. So if we take 1 inch, 2.54 centimeters, we're left with 55.7 over 2.54, and this would be in our desired units of inches. So again, we're just going to divide 55.7 by 2.54. I'll give you a quick second to do that. And what we should end up with is 21.65 inches. So you should be following this a little more closely by now. Again, we want to take the number that we're starting with, 55.7 centimeters, and multiply by some conversion factor that's going to eliminate the unit that we're looking to get rid of and give us the unit that we want to be working with. So we're going from inches to centimeters here. We had a direct conversion, 2.54 centimeters to an inch, and we end up with 21.65 inches. So if we go a little further down here, this next example, we have, if a person measures 67 kilograms, what is his weight in pounds? So again, we have a direct conversion here between pounds and kilograms, so we can just plug that in here. We start with 67 kilograms, and we want to eliminate kilograms, so we're going to put that on the bottom. Again, this would just be over 1, because you can put anything over 1 and it doesn't change its value, right? So kilograms and kilograms will cancel out here, and we want pounds, so that's our direct conversion. We have 1 pound is 0.4536 kilograms, and that would leave us with 67 over 0.4536. So if we divide that out, again we have our units of pounds left. I'll give you guys a second to do that. So what you should end up with here is 147.7 pounds. So the three that we've had so far are pretty straightforward. We have a direct conversion between these three problems. Each of them is only one step. So what if we have something that might require more than one step? How many seconds are in 7 years? Well, you could look up a conversion directly from seconds to years, but we're going to pretend that we don't have access to the internet here, and we're going to have to work with things that we know in our head. So if we take our original unit, or our original measurement of 7 years, we want to multiply by some conversion factor here. So we have years and we want to get down to seconds, so let's work this one step at a time. We know that in 1 year, which we want to be on the bottom, so that years cancels with years, we have 365 days. So now we're in days, which has gotten us closer to seconds. So we're going to multiply by another conversion factor here. We're looking to get to an even smaller unit of measurement, so we want to put 1 day on the bottom, and that would be 24 hours. So now we've eliminated days here, and we're left with hours, which is closer to our unit of seconds, but we're still not there yet. So we have another conversion factor. We could put hours on the bottom here because we want it to cancel out, and we know that in 1 hour there are 60 minutes. So we're in minutes now, which is almost to seconds. So if we put minutes on the bottom so that it cancels, we know that 1 minute is 60 seconds. Now some of you might have thought here to do 3,600 seconds in 1 hour instead of 2 steps of 60 each here. That would be fine, whatever mental math you can do in your head. So we have our final desired units of seconds. We've canceled out one step at a time here: minutes, hours, days, and years. And so through this 4-step conversion process, we've ended up with seconds. So what we're going to do here is multiply straight across the top with 7 times 365 times 24 times 60 times 60, and straight across the bottom, which we would have a 1 here, would be 1 times 1 times 1 times 1 times 1, will just give us 1. And our desired unit that we've got is seconds. So we just need to do a quick multiplication here. I'll give you guys a second for that. So what you should end up with here is kind of a big number, so we're going to put it in scientific notation eventually, but we have 220752000. So a big number here. Whenever you get a number like this, it's really good practice to put it into scientific notation, and that way it's a little less cumbersome when you go to put it into lab data or anything like that. So we have 1, 2, 3, 4, 5, 6, 7, 8 decimal spots here, so it'll be 2.2, let's round it to 1, times 10 to the 8th seconds, and that's in 1 year. In 7 years, sorry. So this was a little bit more involved than the previous conversions we've done, but it's really the same process. You want to take the number that you start with, and that's always step 1, is to take the measurement that you're given, and we want to convert that slowly but surely, eliminating units until we get to our desired unit of seconds. So we took years, canceled that out with days, canceled days out with hours, canceled hours out with minutes, minutes with seconds, and we end up with seconds at the end. So let's try one more here. How many square inches are in 93 square centimeters? So the key here is square. Let's take an inch, and using our conversion from before, we know that's 2.54 centimeters. So let's say we have a square inch here. We know that this side is 1 inch, and an equivalent side would also be 2.5, well, let's call it 2.5 centimeters. So if we were to break this up, this side would measure 1 inch, and this side would measure 2.5, so we would have 2.5 lengths here, in this one length here. So what we can't do is just convert 2.5 to 1 directly, because if we have a two-dimensional figure here, a square, we're going to have two conversions, because this side is 1 inch as well, and this side will also fit 2.5. Again, this is not to scale, but roughly 2.5 sections here. So what we need to do is have two conversions, because we're going to have 2.5, and we're going to make a little kind of grid here. So we have 2.5 times 2.5. The area of this would be 6.25 centimeters squared. The area of this in inches would be 1 inch squared. So because it's a two-dimensional figure, we have to multiply it by as many dimensions as we have with the conversion. So we would do 1 inch squared equals 2.54 centimeters squared would be 6.25 centimeters squared. So we're going to use this concept to approach this next problem with the same exact strategy. So if we take the number that we start with, as we've done before, 93 centimeters squared, and then we want to again multiply by our conversion factor. So we need centimeters squared on the bottom, and we can put this over 1. We want inches squared on the top. So we have 1 inch is 2.54 centimeters, but again, we want to square this because we have two dimensions. So this will really be 2.54 squared. So this we could turn into 93 centimeters squared times 1 inch squared over 6.25 centimeters squared. If we multiply straight across the top, straight across the bottom here, we would end up with 93 over 6.25. I realize that I've used the rough estimate of 2.5 again here. We'll just kind of change this, but the process would be the same for 2.54. You would just punch that into your calculator, get a slightly more accurate value here, but the strategy is really the same. So here we would just divide 93 by 6.25, and we end up with 14.9 inches squared. So this is a new concept here. If you have multiple dimensions, you need to convert by that many dimensions when you go to do your conversion factor. So we had two dimensions here, so we squared the conversion factor to appropriately convert. So we've got one last example here. If a car is traveling at a speed of 48 miles per hour, what is its speed in meters per second? So we're taking our initial measurement, 48 miles, and now we have a unit on the bottom. We'll put hours down here, we can put a 1 there. And we want to get this into meters per second. So really you just want to take this one step at a time. We can work with the miles first, and we want to convert miles into meters. So if we go back up to the top here, we have 1 mile is 1,609 meters. So (1,609 meters is 1 mile. We've eliminated miles here and gotten to meters, and that's one of our desired units at the end here. So now the last thing we have to do is just convert hours into seconds. So because hours is on the bottom here, we're going to have to cancel it by putting it on top. So hours and hours. We're looking for seconds, so I mentioned before we can just really do a direct conversion here. There are 3,600 seconds in 1 hour, and again that would be 60 minutes times 60 seconds would give us 3,600 seconds there. So now we've eliminated hours, we've eliminated miles, we're in our final units of meters per second. So again, we'll just multiply straight across the top and straight across the bottom. This would be 48 times 1,609 would give us 77,232 on the top, and 3,600 times 1 times 1 would give us 3600 on the bottom. So this we have in our desired units of meters per second. So the final step, divide this out. We have 77,232 divided by 3600, and that would give us a final measurement of 21.45 meters per second. So I hope this strategy has been helpful in helping you understand unit conversions, and I'll see you in the next lesson.